Hi guys and welcome back to my channel. Today's video is going to be on Markov chains. So this is a little big topic, so I would like to cover it in two parts. So this is going to be the part 1 and we'll have another part 2 on my channel. So stay tuned for that and let's begin with the basics of the Markov chain. So Markov chain is a stochastic model which describes how a sequence of random events evolves over time. So the main points that you should know out of these is that it describes of how a sequence, of random events evolves over time. Right. So time is something that we measure in discrete steps. So these are the main points that you need to know when you are actually making a Markov chain or you're making that Markov model. So each time step that you have will have possible outcomes of each event, which are called the states. And the first state is called the initial state, and further they are called the states. Then, the third point is something that I'll be discussing later in the video because I don't want you guys to get confused with it right now, right? So let's get into the video right now and look at an opening problem which will describe this Markov chain and help you understand this whole concept. So I'll be using an opening problem and explaining you guys the whole concept using examples. So first of all, I would say these are the things that have been given to us. These are the pointers that we have to know. So first of all, time is measured in days. Each day the weather can be either sunny or rainy. So we have two options: either it'll be sunny or rainy, one of those. And tomorrow's weather will only be dependent on today's weather. So these are the 3 points that we need to know, and these will be given to you. So using these, you will have to make the Markov chain. So now let's look at it. Markov chains has a subtopic called the transition diagrams. So this is what will illustrate the previous thing that we just read. So the pointers that we just read, those 3 pointers, will help us in making this diagram. So now let's try to understand what exactly is this diagram about. Before that, this tells about how the weather changes or transitions, right? How the weather changes, or just a second, transitions. And from one day to another, this will, I will just repeat that, transitions from one day to the next day using this transition diagram. So let's begin. So you guys can see that we had only two options. It will be either sunny or rainy. So we'll make a kind of these circular 2D shapes, which will which will be which will be there to be written with the sunny or the rainy or whatever options you have. So we have sunny and rainy, so we just write that over here. Here you can see that easily. Now let's try to understand slowly, and I'm sure you'll get the grasp of the topic. So the probability that the weather will be sunny tomorrow if it is sunny today. Or I'll just explain it to you guys in my words. So on both days, if it is sunny, that means it is sunny going sunny, and it is also the next day sunny. Understood? So the probability of that is 0.8. If today it is sunny and tomorrow it is rainy, it is 0.2. Because it is going from sunny to rainy. So it is sunny to rainy. So day 1 is sunny and the second day is rainy. Over here we saw that it is coming back to sunny. That means day 1 was also sunny and day 2 is also sunny. The other option that we have is day 1 is rainy as well as day 2 is rainy. So let's just write them down. So we have sunny and then rainy. I'm just writing S and R for that. Then we have sunny and sunny. We have rainy and rainy. And we have rainy to sunny, which means one day is rainy and the other day is sunny. So rainy to sunny, right? Now, you guys can quickly read through these, and I hope you will understand this after I've explained this to you. Because if I did not explain it to you, this would be a little hard to understand, but just read it now. This one says, probability, it will be sunny tomorrow if today is also sunny. So sunny on both days, which is this one. Then we have probability it will be rainy tomorrow and sunny today. So it means sunny today and rainy tomorrow. This is one. Then we have rainy today and rainy tomorrow, which is this one. And rainy today and sunny today. So you guys can see this is rainy to sunny, which is this one. I hope you guys understood the transition diagrams. We'll look at this in more depth, but let's move forward for now. So one thing I would advise you to guys to keep in mind is how it should be represented. So the states that we have, which is either sunny or rainy, whatever, state has to be represented by a circle, which is this one, as well as this one. Arrows should show the movement between the states, which we've already seen over here, This movement is shown by an arrow. We have arrows here. I'm just going to erase a little part so that you guys can see it. You guys can see that there's arrows which are actually showing the movement. You guys can see this point over here. Then arrow should be labeled with the transition probability, which again you guys can see. Here we have it is both day rainy is 0.4, rainy to sunny, first day rainy, second day sunny is 0.2, and similarly we have others 0.6 and 0.8. Now, let's move forward if you've understood these key points of the representation of the transition diagrams. Now we will try to represent the matrix representation. So we have the Markov diagrams will be either in the transition diagrams way or looking at the matrix representation. This is used to study the Markov chains using matrices. So if I talk about the state matrices, we show it by SM, shows the state of system at time n. State matrix may represent either the probability of the proportion of population that is there in each state or the actual number of population that is there in the given state. As I told you, initial state matrix is the first matrix to start with and it is represented by S0, something like this. So we looked at the opening problem and now we are supposed to have the time step of n equals 0. So if it is sunny today, then the initial matrix will be sunny today is the probability of 1, 0, or 1, and rainy today will be the probability will be of 0. So we just looked at the example of the opening problem and how it is represented in the initial state matrix. Now looking at the transition matrix. So for the transition matrix, we can clearly see that T denotes a transition matrix and it should be a capital T for that sake. So we see that over here, right here. You guys can see that it is T over here, right? And we represent this as T equals small tij. So we'll see what this actually means right now. So the columns represent the current state and the rows represent the next state. We'll look at this by what I mean is that we'll discuss this in a second, but before that, let's see what is Tij so that you get clear with that particular point first. So I represents the next state and the current state is J. So once you know that, the Tij is the probability of moving from for moving to state I from state J. So if I have two states over here, I'll say I, and if I have a J, so moving to I from J. So what we've done is we moved to I from J. So that's how you actually speak it, right? So the sum of each column should be 1. Okay, let me just go further and you'll understand what I mean here. So over here, you guys can see that clearly that there are columns as well as rows. So this is equal to T, which we just saw is equal to Tij. So Tij equals to T. So we saw that. Now, looking at this representation, we can clearly say that the sum of each column, which you see this column is equals to 1 and this column is also equal to 1. So we can say that the columns, or I would say each column equals to 1. So the transition matrix for the Markov chain for the opening problem that we were looking at is something like this. Now I'll look at this in a little depth so that you understand how exactly is this representing transition matrix for the Markov chain. Guys, for this particular transition matrix, we can see that it is today and tomorrow. So we have two timestamps, right? And we have two different states also. We have sunny and rainy. We can see sunny, rainy, and then we have sunny, rainy here as well. So now, if I say that if it is sunny today, so if the thing is sunny today as well as sunny tomorrow, the probability for that is 0.8. Today will be rainy and tomorrow will be sunny. We have the probability of 0.6. Sunny on both days will be 0.8. Rainy on the first day and sunny on the next day is 0.6. Sunny and rainy on the next day is 0.2 and rainy on both days is 0.4. I hope you guys understood this part, this transition matrix, and how you are supposed to really get this, get this in your brains and how to understand this. So you will read like sunny and sunny is this, rainy and sunny is this, sunny and rainy. So you'll just have to somehow grasp this thing. I'll just last time explain this to you, and if you understood, you can move forward. But if anyone is still not clear, you can listen to this again. So what you'll do is you will find that both the races is sunny. So you see where is sunny? Sunny is right here. Then you see that where they're intersecting. So take a line from here and take a line from here and see they intersecting this, which is 0.8. So that means sunny on both days is 0.8. If I just use this for another question, if I see what is sunny on the second day and rainy on the first day. So rainy on the first day is this line. Sunny on the second day is this line. So you intersects over here, which is 0.6. I hope you guys understood this much. Now let's move forward. So we were looking at this particular area. So here we see more moving forward. We have understood this particular diagram. Now let's go forward and see what next we have for this video. So this we've already done many times in our life. This is called the tree diagram. So tree diagrams are much easier than making the Markov chain and calculating the future probabilities, but when you use tree diagrams, it is a little harder and little complicated when you go further and you increase the number of days or the number of time. I would say the time you will increase. When you increase the time, it becomes more complicated and harder to analyze it after a certain, after a certain number. So now we'll first see this particular tree diagram, and then we will say how is it better to use the matrices to calculate the future probabilities instead of using the tree diagrams. So we can see this tree diagram shows here that this is the initial matrix 1 and 0. So we know that the initial matrix is 1 and 0. So this is the S0, or I'll just write initial I for the initial part. So the initial matrix is 1 and 0. So today it will be either it will be sunny or rainy. Tomorrow it can be either today sunny and tomorrow sunny. It can be today sunny and tomorrow rainy. So this will be both days sunny, right? Then we have that sunny on the first day and rainy on the second day. Rainy on the first day and sunny on the second day. And rainy on both days. So we can have any possibility. But what happens is when you increase the values, so this becomes 8. When you increase it, because everyone will have 2 coming out. Then you see when you increase it further, it will become so complicated to really understand. So that's why we prefer matrices over tree diagrams. You guys can see how complicated this has become. That's why. Now let's see what is matrices. After I hope you guys understood why is matrices important. Now we'll use the conditional probability that we used in the tree diagrams to help the calculations to take place. So if I use the tree diagram to calculate, you can see that if we have to take out the probability that it is sunny tomorrow, so it can either be, just give me a second, I'll erase this part. Right, so it can either be sunny today and then sunny tomorrow, okay, or it can be rainy today and then sunny tomorrow. So we just have 2 options, so we'll add them. So we'll do 1 into 0.8 plus 0 into 0.6, which you can clearly see here, and you get your answer for the probability that it will be sunny tomorrow is 0.8. Similarly, we can do for rainy tomorrow as well. In case it is rainy tomorrow, so we have sunny today and rainy tomorrow, or rainy today and rainy tomorrow. So we have these 2 options, just add them and you get 0.2. Now, if I have to take it out using matrices, it will be much easier for us. So let's look at it first. Okay. Here we can see that, just a second, yes. Here we can see that this was the matrix which was given to us over here. I'll just show you guys once. Here. So this is the matrix that we were talking about. This is the transition matrix that we had. So what we will do is, we will to find the TS0, right? We will multiply the transition matrix with the initial matrix and we will get our answer. You guys can see we are getting the same answer as the I would say as the tree diagram. We are getting the same answer. So the probabilities of each state after 1 day is given by S1 is equal to TS0. Okay. So if you want to find out how will it be tomorrow, what you can do is you can multiply the transition matrix with the initial matrix. So T is for transition matrix, this T is for the transition matrix, and the SO is for the, I will say, the initial matrix. Okay, I hope you guys understood this much. Moving forward. In this, you can clearly see that after 2 days, if I want to find out, what I will do is, I will just simply, for S2, I will take TS1. So we just found out the S1 over here. So what we will do, transition matrix into S1. So S1 is 0.8 and 0.2, which is this. This is the S1, which we just found out. And this one is the transition matrix that we are using initially also. So just calculate this, just multiply it, and you'll get the answer. So what we can generally take out from this is that S into whatever, whatever number. So I'll write Sn will give you the Tn and into the initial matrix. This is what you can conclude, and this can be called the formula for this. Now, if I have to take the T S3 out, let's take out the S3 so that you will just be clear that yes, it is possible. So for S3, what we will do is so what I'll do is we need to find out S2. So we took out this part. So what we will do is we will multiply the transition matrix, which we have over here. So so S3 will be the transition matrix that we had into what we just got as the S. So what we'll do is transition matrix into the initial matrix, or the what we will just do is multiply this with this. So once we multiply these two, we will get our S3 for the third day. So I hope you guys understood this much. I did not want to make this video more lengthy, so I'll continue with this topic in the part 2. So stay tuned for the part 2, and I hope you guys understood this concept. Any doubts that you have, please put them in the comment box. I'll surely try to answer them. Now, if you've loved watching this video and if you've learned something from this video, please don't forget to give it a thumbs up and hit the like button, and also please subscribe to my channel for more interesting videos. Thank you, bye bye, and have a really nice day.